In the early 1970s, the two titans of the synthesizer world were Moog and Arp. Mini-Moogs were everywhere, and Arp answered with the Odyssey, a two-oscillator monosynth that had a unique duophonic keyboard, meaning that you could play two keys at once, taking one oscillator per key for some cool effects. Odysseys are highly sought after these days, and we've come up with a way to make that mean, gnarly sound unbelievably fat. It takes a new circuit board and some power tools to put it together, but that's the sort of thing that gets us excited. Here at Syntaur, we live to bring old synthesizers back to life. We find vintage keyboards wherever we can, and our crew restores them back to their original splendor. We also supply parts to tens of thousands of customers all around the world so that they can restore and repair their own keyboards. At our shop in Texas, we have on hand parts for the synths used by pros from the 1960s all the way to today's brand new keyboards. Our inside and out knowledge has made us known as the Synth Wizards. Arp Instruments was founded in 1969 by Alan R. Perlman, an engineer who had previously been designing electronics for the Gemini and Apollo space programs. Arp started off making large systems like the 2500 and 2600, but then Mini-Moogs started appearing everywhere, and Arp responded with a compact Odyssey synthesizer in 1972. It packed the sound and flexibility of the bulky 2600 into a portable two-oscillator beast, and it was wildly successful, so much so that over the next decade, Arp ended up making 3 versions of the Odyssey, with several different filter designs. The Mark I Odyssey is commonly called the Whiteface, and with its oscillator sync, pulse width modulation, ring modulator, and extremely stable tuning, it offered fierce competition to the 3-oscillator Mini-Moog. The 2-pole filter in the Whiteface was biting and aggressive, and the Odyssey became known for its snappy and zappy sounds. Notably absent are pitch bend and mod wheels. Moog used them, so Arp refused them. Instead, a single knob on the front panel of the Odyssey adjusted the pitch up or down. Not a great setup. The Mark II Odyssey, released in 1975, sported a gold-on-black color scheme and some handy new features such as CV and gate jacks on the back panel, as well as an input for patching external audio through the synth. The filter used in the Mark I was now replaced with a ballsy 4-pole VCF. But this new filter was based on a design patented by Moog. After some legal sparring between the two companies, later Odysseys were given yet another filter design, this one darker and gentler. It turns out that a miscalculation in component values caused the filter to pass nothing higher than 12 kHz, even when wide open. Fortunately, this is pretty easy to correct, just by replacing 4 resistors. 1978 saw the release of the Mark III. It was orange on black, and the awkward pitch bend knob was replaced by a set of rubber pads called proportional pitch control. Pressing harder on the pad to the right bends a note upward, for instance, and pressing on the center pad adds modulation to the sound. The questionable change on the Mark III was that the keys were no longer recessed behind the front edge of the synthesizer. They now poked out of the cabinet almost a full inch, unprotected and dangerously susceptible to breakage. Arp closed its doors for good in 1981, but over 3 decades later, in 2015, Korg recreated the Odyssey once again. Using almost identical circuitry, Korg reintroduced all 3 color schemes, but scaled them down in size from the originals, even using miniature keys. And in 2017, there's a limited release of Korg Odysseys once again, this time in full scale. One of the cool and interesting things about the Arp Odyssey, and one of the unique things, is that it has a duophonic keyboard, and here's what that means. Unlike most monophonic synthesizers, you can actually play 2 notes at once on the Odyssey, and what it does, you have 2 oscillators per note. When you play 2 notes, it takes 1 oscillator and assigns it to each of those notes. I'll show you what I mean. That's regular playing, and now I'm going to play 2 notes at a time, and you'll hear they both play. So both notes are playing, but they only have 1 oscillator apiece, so you kind of lose the fatness of the sound, but it still makes the Odyssey pretty unique, and you can do some nice special effects that way. In the Joe Walsh song, Life's Been Good, at about 3 minutes into the song, there's a little synthesizer, burbly kind of breakdown part. That synthesizer is an Arp Odyssey. And here's how they did the sound. Here's a rough approximation of it. First of all, they programmed just kind of a bass note to play the same pitch no matter what key you're playing. Then on top of that, they used the filter in self-oscillation mode to actually make a pitch that does track across the keyboard. And I'm going to crank up the filter here and you'll hear it come in. There it is, starting to self-oscillate and make the pitches. And so now so that's basically how they did that sound in Life's Been Good, Arp Odyssey. Whenever we start a new refurbishing project at Syntaur, I usually start dreaming of ways we can make the synthesizer we're working on even more special. What can we make it do that it couldn't do before? The Odyssey is already very versatile, but what I miss on it is a 3rd oscillator. That's a big part of what makes the Minimoog sound so fat. Adding such a thing would be a huge undertaking, but adding a sub-oscillator to each of the VCOs is much more doable. This would give the Odyssey 4 oscillators, sort of, and that's something to get excited about. So we set about making this happen. Each of the sub-oscillators is going to require volume control on the front panel. That means mounting a potentiometer there. That means drilling a hole in the front panel of a valuable collectible synthesizer, so this isn't a project for the squeamish. Then we've got to build a custom circuit board that does the mojo. And the way all that's going to work is by using a flip-flop. To understand how our circuit does this, let's first picture the Odyssey playing a square wave with just a single oscillator. If you were able to see the actual sound wave, it would look very squarish and it would sound rather hollow, like this. Our circuit uses an IC chip called a flip-flop, and here's what it does. We feed the Odyssey's wave into the flip-flop, and every time the waveform starts going in an upward direction, it triggers the flip-flop. One upward trigger, and it flips, putting out a voltage. The next upward trigger, it flops and puts out nothing. Next trigger, it flips again, and there's voltage. Then it flops, and so on. The result is another square wave, but this one is exactly twice as long as the original. And according to the laws of physics, that makes a sound exactly 1 octave lower than the original. No matter what type of wave we feed into this circuit, it will always put out a square wave 1 octave lower. Then we just use a potentiometer to mix that in with the original signal, and we get a sound fatter than yo mama. When we part out keyboards at Syntaur, we keep everything that can possibly be used to bring other keyboards back from the dead. We end up with a lot of metal cabinet parts, so every now and then, we haul a truckload to the metal yard for recycling. Recycling these parts is far better than putting them into the landfill. We even end up making a few dollars on the side. If you own an Odyssey, or even if you'd like to, you should know about the repair issues that are common to this synthesizer. First of all, the sliders suck. They're going to eventually gunk up and get scratchy and really stiff. While contact cleaner like Deoxit is generally great for scratching the scratch in a slide pot, in these particular pots, it also dissolves the grease that helps them move easily. The best bet is to remove the pots from the circuit board, take them apart, and clean them by hand. It's a lot of work, but hey, that's the price of admission to owning one of these. I did a video a while back that details the entire process of cleaning these pots. We see a lot of ARPs with broken slider stems, and that calls for either replacing the entire pot or taking the slide pot apart and replacing just the stem itself. You'll also want to get familiar with cleaning the key contacts, because dirty or oxidized contacts will make notes play either with crazy pitch problems or to go silent altogether. Rubbing alcohol on a Q-tip works great for cleaning the J wires and the bus bars they make contact with. Don't use anything abrasive here, as it'll remove the silver coating on the wire and make the contact problem even worse. Finally, the slide switches in the Odyssey also get dirty, and you'll start losing the features they control. This trouble is solved easily with a quick spray of Deoxit into the side of the switch mechanism, followed by a brief exercise regimen. Really, one of the things that causes trouble in an Odyssey is simply not playing it. The motion of the sliders and the key contacts against the bus bars keeps those contacts clean. So a good maintenance tip? Play it often. That should be easy enough. If you own a vintage synth, it's a great thing to be able to calibrate it without having to take it to a service center. It's hard to find shops that know how to calibrate old analog gear these days. While a full calibration usually involves quite a few steps, beginning with the power supply, the most critical thing is the tuning of the oscillators. If they're off even a little bit, it's going to be very noticeable in your playing. Here's a quick overview of how the general tuning process works. If an oscillator is out of calibration, the first thing you might notice is that when you play a note, middle C for instance, the sound that comes out isn't really a C, it might be an F sharp. You can correct this, of course, with the main tuning knob, but to make it right, you'll want a C to really play a C when that tuning knob is centered. There will be a trim potentiometer somewhere on the circuit board to dial this in for each oscillator, and it'll usually be called tune or pitch, or on the Odyssey, frequency calibrate. Once you get the C key to actually play a C note, you might notice something else, that the oscillator doesn't stay in tune as you play up the scale. By the time you get to the next C an octave higher, you might really be hearing a D sharp. So the tuning is stretched out or compressed so that an octave of keys plays either more or less than an octave in pitch. There should be a trim pot for this as well, usually called something like oscillator scale, or on the Odyssey, volts per octave. So here too, you make an adjustment so that an octave of keys really plays an octave. The tricky part is that these two adjustments, tune and scale, work together to drive you bonkers. Whenever you adjust one, it affects the other. So after you adjust the scale, you might find that now the basic tuning is off again, and you've got to get middle C back to playing middle C. And after you do that, your octave scaling isn't right anymore. But if you're working in the right direction, each of these adjustments is getting better with each iteration, so just keep at it until the overall tuning is right. This can be tedious and maddening, but it's all part of the fun, or the madness, of owning an analog synthesizer. To install the sub-oscillators in this Odyssey, we first built and tested a prototype circuit to make sure everything worked the way we wanted. Then it was time to get out the power tools and put it all together. With the Odyssey disassembled, we measured and marked the inside of the top panel where the holes would be drilled for the new potentiometers. We had to get the controls in a logical place on the front panel and make sure that the pots would clear the Odyssey circuit boards on the inside. Once the holes were marked, I drilled small pilot holes through the panel, then drilled the holes out large enough for the pots. Then we mounted the two pots that control the volume of each sub-oscillator and began wiring them to the circuit boards. We replaced one of the Odyssey circuit board screws with a standoff, and this gives us a mounting point for our new circuit board. The sub-oscillator board is pretty tiny, so all it takes is a single screw into this standoff, and the PCB is secured. Then it's just a matter of hooking the wires to the right places. One wire brings power to the board, another is the ground, and then the others feed the original signal into the circuit and deliver the sub-signal back to the Odyssey. Once the wiring is all done and the interconnect board is back in place, all that's left is to put on some knobs, button it all back up, and this Odyssey is ready to get down to business. On the previous episode of Synth Wizards, we built a heavily customized Roland Juno 106 that we call a Syntaur Juno 107. It turned out so amazingly cool that I've been reluctant to sell it. But it's time to move forward, so we're listing it on Reverb. We need to turn it into cash so that we can get going on the next project, but I know that I'm really going to miss it when it goes. Getting the sub-oscillator circuit dialed in perfectly called for a bit of trial and error work to get the output level of the subs to match the output level of the main oscillators. So Joel fine-tuned some resistor values until we were happy with the oscillator mix. Then we turned the Odyssey back over to Gerald for the final checkup and reassembly. I love this stage of the game, when the final product is going together and it's looking and feeling like an instrument again, instead of like a big pile of wires and circuit boards. It's a happy moment when Gerald says, "Here, it's all yours. Now get it out of my room." Just sitting here all day crying over it.
Well, I hope it goes to home, and that they'll love it as much as you do.
I do love it.
Mm-hmm. Maybe the next one will be like red or gray. Would it be a 108 or 107?
I don't know if Gerald would do that one. Well, the good news and the bad news is we sold the Juno 107 on Reverb. I'm sad to see it go, but it's going to go to a happy home, and that's what needs to happen. So before we start putting on the bubble wrap, I'm going to give it one last run through and tell it goodbye. It's so cool. Turning it off for the last time.
You gonna be all right over there, Sam?
I'll get the tissues.
Okay, I have a basic Odyssey patch going here. It's two sawtooth oscillators tuned in fifths. And now I'm going to add in those sub-oscillators and see how it fattens up this sound. Sub-oscillators in and now out. Sub-oscillators in there. And then we take them out. You can tell it really beefs up that sound. Okay, here's a basic, this is using square waves with pulse width modulation. That's without the sub-oscillators, and now let's add them in and see how that sounds. Sub-oscillators out. And back in, big and beefy. Not only did we end up with a hot-rodded Odyssey, we ended up with a new product as well. Syntaur is now selling a kit to add sub-oscillators to your vintage Odyssey. We've got the circuit board, pots, knobs, and all the wiring. You just need to drill the panel for the controls and solder a few wires. So kids, you can try this at home. In the meantime, we'll be putting this hot rod Odyssey up for sale and seeing what's in store for the next Synth Wizards.
And the next knick-knack.